welcome you all again on the YouTube channel of TEQIP classes. So this is all about me, and we were studying about the machining and the machine tool operations. So PI student can also join this subject. Okay. So in the last lecture number 18, not in the last lecture, but from the 15 to 18, we were discussing about the milling machine only. And in the last lecture number 18, we discussed about the indexing part. So I hope that that indexing in the milling machine is clear to you now, and you are able to solve the problems, whether it's numerical problems or objective types of the problems that has been asked previously in engineering services or GATE examination or any other examinations. So in the today's lecture, lecture number 19, we are going to discuss about the shaper machine. Okay. So once again, I welcome you all on the Let's Crack the Gate along with the TEQIP faculties. Okay. So let's start. Okay, so about the shaper. First, generally this shaper machine is used to produce the flat surfaces. Flat surfaces means if you will see this one, means these are the flat surfaces. Flat surfaces doesn't mean that you have this rectangular bar, okay, and it has some specific length. Okay, it doesn't mean that you will produce means you will use to remove the material of a specific depth of cut only. Okay, it's not like that. Okay, if you have to make any kind of the slot, which is it's like square, rectangular, V shape, okay, whatever it is, so it should be flat. Like for an example, this one, like this is a groove. Okay, this is also a groove. This one is a T slot. Okay, so if you see the surfaces, then it will be a plane or flat surface. Okay, okay, it should not be a curve. So whenever we have to produce the flat surfaces, we can use the shaper machine. Okay, generally it used to produce the grooves, T slots, and dovetails. These are the dovetails. Okay, it can be like this as well. Okay, so to produce these things, so that's why we are using the shaper machine. But at the end, because it has a very wide structure, because it's a complete mechanical instrument. So whatever the area of this machine has been that cover, that is very large, and as comparatively means what is the productivity of this one? This is the productivity is very small. Okay, means very less. So that's why very few time we are using these machines, and even though industries are also not prefer these machines, because on behalf of these other machines are available, so that we can utilize that and produce the parts and increase the productivity. Okay, so that's why use shaper machine is lesser in the use, but we have to study from the examination point of view. Okay, so first I'm briefing with you with the main components, then we'll go for the working part. Okay, so we start from the bottom part. This is a this portion is the base. Okay, over that this side is the column. Okay, column is, now it's clear to you that we have studied from past three machines. Okay, from last three machines we have seen that column is nothing but the part of the machine in which the gear assembly or the this input unit or like electrical assembly is mounted over there, spindle is mounted over there. So this is the column in which this whatever the geometry that we are using, means whatever the mechanism that we are using, we are mounting over here. Okay, over that we call it as a ram. So this ram is nothing but here we are using this ram to provide the reciprocating motion. Okay, now this reciprocating motion means motion means if this is the tool, then it is moving toward this side, then again coming back, then moving toward this side, then coming back. Okay, so this is the reciprocating motion. Now this tool is moving first toward this side, okay, then again it is coming back this side. So this is nothing but a reciprocating motion. Over that, basically this we call it as a clapper box. Okay, now we are giving there is a feeding mechanism is mounted over there. Okay, over this clapper box. Okay, let's just wait. This clapper box is connected with a tool. Okay, this tool is nothing but a single point cutting tool only. Okay, so this single point cutting tool is mounted over a clapper box. Okay, so this over this clapper box, as I said, there is a feeding mechanism is available, so that it's like glue only, okay, like screw and nuts. So we are tightening this screw, this is moving toward downside, we are loosening up, then it is coming up. So if we have to provide a little movement, it doesn't mean that we are giving a feed, depth of cut to the work, to the tool. It doesn't mean like that, okay. If there is a little movement is required, if we have to fix in a proper way a single point cutting tool sometimes, so that time that's why we are using a feeding mechanism over there, okay. Apart from this, sometimes back side to this portion, this front portion, over this portion, the angular displacements are there. Angular displacement means आपके angles बने रहेंगे from 0 degree to 360 degree, so that if we have to rotate this clapper box, okay, rotate this means like there is a specific range is there, so we have to rotate it, then we can like if this is the tool from front side, this is the tool, then if you have to rotate it, then this is mounted with a clapper box, so you can rotate this clapper box. Just assume today that this portion is up to here, from here to here it's a rain body, then this is the clapper box, this one, and this is a single point cutting tool, okay. So it's like we are moving toward this side, this is the forward, this is the means forward stroke, this coming back, this is the return stroke, okay. So next is this is nothing but the this is a knee portion, what we have seen in the other machines or in the milling machine especially, that knee is nothing but where the feeding mechanism is mounted. So here, like if we have to move this body over this side, X direction you can say, this is Y direction you can say, and this is Z direction. So if we have to provide the X, Y and Z motion, then we are using, okay, then we are using this one, okay. And over that basically this fixture is mounted. This is nothing but a fixture, okay. Fixture is generally we use to hold the workpiece. So basically we are mounting the workpiece inside this one, and there is like another mechanism is available. So here also like feeding mechanism, feeding kind of things like screw and nuts again. So nut is nothing but the part of this body only, fixture only, okay. Over that, inside that there is a screw is mounted. So basically if whatever the thickness means, initially we have taken like we have taken this one as a standard generalized, okay. So if the length and the width of this workpiece is lesser than what we have chosen the standard value, then what we have to do is we have to fix it, okay. So what we are doing, we are just using this one, okay. When you will do it, this will move toward this side. So just try to assume that if this is the workpiece we have mounted in the this one fixture, then through this side you are tightening up so it can be fixed, fine. Now this is the parts. Now we are going to the working part. Working, like we are using the single point cutting tool. So as I said that when we are this is the rim and this is the clapper box, just assume, and this is the single point cutting tool. So single point cutting tool, so when okay, so this is the single point cutting tool, and this portion rake face, okay, we are keeping this rake face in the front side, okay. So when we are keeping this one in the front side, so what will happen when it will move toward this side, this will remove the material and again it has to come back. So because reciprocating means is this reciprocating is in like if I'm saying that this is the Y direction, so this reciprocating motion is in Y direction only, okay. It's not like this tool is moving towards X direction as well, okay. It's not like that. It is fixed at a position, means it will not, we cannot give the feed is not, this is not a feed basically, this okay, you can say this is the feed, but this is not the feed which is provided by manually. It's like through the knee, it's like it is reciprocating, so that's why it is getting a feed, okay. So now toward this side, this is the forward motion, then it is coming back, so this is the return motion. In other words, I can explain you that this is the like this is the body, okay. We have to remove the material. So again the same way, like this is the like way through which we can hold, and this is the clapper box over this tool is mounted. So we are moving toward this side, then again coming back. Now we are moving to side, this side means first from here we are removing the material, then again coming back, then we are moving toward this side, then it's like that. Okay, this is the one way. Another way was this one. We have also discussed in the generatrix and the directrix class. So first this one, then again coming back, then we are moving towards second, then it is coming back, then third one, last one. So it's like that. Okay, so how much whatever the width you have taken, accordingly we are dividing that, we are taking this feed. Okay, and the material is removed. So this is basically the process of this. Now the important part of this one is that what we are using in the column over here. So that which mechanism, by the way, like just think that if we are using, okay, I will explain you that in that part. Let's move to the next one. Okay, so here if like means I'm not directly going towards toward this to explain you this, because I just want to brief you that why we are using that one. Okay, because whenever there is an innovation, there will be something that we are unable to do, okay, before that. So that's why we have innovated something. So if we are using this one, this mechanism, okay, all of you, maximum of you are aware about that this is the conversion of the kinematic chain. So why we are using this one? Okay, this is also important. So like if this is a cylindrical, this is a disc basically. Okay, now in this mechanism what we are doing is we are just there is at the inlet there is a rotary motion, at the exit there is a reciprocating motion. So what we are doing, we are converting this rotary motion to the reciprocating motion. Fine. Now this is just assume that this is a disc. Okay, this is a disc, just this is a disc, circular disc. Over that basically we have like एक screw or anything, a shaft you have taken and you have hold it. आपने यहाँ पे क्या किया है, इसको वेल्ड कर दिया है. ठीक है, यहाँ पे मान लीजिए आपने इसको वेल्ड कर दिया है. ठीक है, सो इट विल बी लाइक ये आपको इस तरह से दिख रहा है एंड वेल्ड आपने किया तो दिस विल बी ट्रीटेड, मतलब परपेंडिकुलर देखेंगे तो पॉइंट ही दिखेगा. सो वेल्ड आपने कर दिया. ठीक है, नाउ दिस इज द रोकर आर्म दैट यू आर यूजिंग. रोकर आर्म अगेन द सेम थिंग you what you have studied previously. Okay, this is the rocker arm. Inside there is a slot is mounted. Okay, now this rocker arm is fixed. Like here we have fixed it, means it will, this is the stationary point. Another point, this one, this will rotate. Okay, or it will reciprocate, whatever. So what is happening that we are giving the rotation to the workpiece, so sorry, to the disc, then it is rotating. It will rotate, then this portion will also rotate. Now it has a standard path basically, मतलब जिस भी radius पे from the center you have fixed that one. मान लीजिए कि ये आपका सेंटर था और इस सेंटर से आपने यहाँ पे इसको फिक्स कर दिया, जो भी आपने रेडियस इनिशियली चूज किया. Now that will rotate about this center only. Okay, so this as it is rotating means हमेशा ये उसी सेंटर के about rotate करता रहेगा. Now what is happening because of that this is the slot bar, slot. Okay, so as this is moving, it is, this slot is over this screw. So when it will rotate, that will also carry along with that. So is position like, for an example, if this is here, this whatever this one over here, now this will be like this slotted rocker arm will be like this in this position. Okay, so now what is happening that it is moving like if you'll see this one, this top portion of this one, then it is moving toward this side, then coming back again, it is rotating, then it is moving toward this side and again coming back. Okay, this is basically happening. इसमें क्या होता है कि if you will see the velocity profile, then this is the positive velocity and this is negative velocity. Negative positive इसलिए कह रहा हूँ, हालांकि दोनों ही पॉजिटिव हैं. नेगेटिव पॉजिटिव इसलिए कह रहा हूँ कि पॉजिटिव जो है दैट इज फॉरवर्ड स्ट्रोक आई एम सेइंग, मतलब जिसमें आपका मटेरियल रिमूव होगा. ठीक है, बैकवर्ड स्ट्रोक है जिसमें आपका मटेरियल रिमूव नहीं होगा, वी आर कॉलिंग इट एज अ रिटर्न स्ट्रोक. फॉरवर्ड स्ट्रोक में मटेरियल रिमूव क्यों हो रहा है? ओके, आई फॉरगॉट देयर. फॉरवर्ड एज आई सेड के लाइक दिस पोर्शन वी आर होल्डिंग this one, this is the cutting this has a cutting edges, okay, and this one is the rake face. Now if you will see the back side of this, this is the flank surfaces, okay, that is free. So when whatever the depth of cut you have taken initially, okay, जो आपने depth of cut लिया है, basically it has a sharp edges, so and also nose radius along with that, or point we can say, so that will remove the material and again it will come back, okay, because it is forward motion and this is a backward motion or return motion, okay. So when it will come back, whatever the depth of cut you have taken, that has been removed from the workpiece. So now when it is coming back, only a little portion of very small portion, and that is not equal to the depth or lesser than that, that portion is coming in contact with this tool. So when it is coming back, basically return back, that time only small amount of the portion that is coming over the contact in the workpiece, okay, of this tool. So it will, like, it can create a problem of surface roughness, okay. There is a chances that while coming it can remove the material, but it happen very less, okay. And as I said that obviously when it will move come back this side, then we have to provide some relaxation to the clapper box, because now in this position it should be like this one, okay. So मान लीजिए कि when it is moving toward this side it is like this, and when it's coming back it will like this. So there will be no surface roughness, but it cannot be possible that it's not like for 1 minute it is moving toward this side and we are holding this one, the मतलब switch off कर दें machine को, and then we are pulling this one and then again switch on करिए, then again switch on करिए, then again switch off, then switch on. It's like we cannot do like that, okay. So what we are doing is we are providing some little angular movement to this toward this side, okay. पहले आपका क्या था, angular movement, there is a possibility in this side. Now you are providing this side. अगर मान लीजिए कि this is your ring, this is your clapper box, so now it can basically move toward, आपका इस तरह से ये हो सकता है, ठीक है. Little angular moment you can provide. So while it is coming back, okay, it will be it will move little bit like this, okay. So it will not rough the surface, workpiece surface, okay. Okay. So why we are using, when you will see this velocity profile, this is a positive direction, this is negative, means forward, this is forward for the forward motion, this is for the return motion. When you will see the velocity profile for this case, this will be like this is the time, okay, along with that velocity profile. So this velocity profile will be like this, okay. Means this is a forward motion, okay, and this is the return motion. Means from here, whatever the along with the time, the length has been covered, ठीक है, यहाँ तक आएगा, then again it is coming back. Means during both the time, in forward motion and the return motion, the टाइम टेकन इज सेम. तो मान लीजिए कि आपका रिटर्न मोशन है, उसमें तो आपको मटेरियल रिमूव हो नहीं रहा है, देन व्हाई आर यू टेकिंग दिस मच टाइम टू रिमूव द मटेरियल. सो व्हाट, देयर इज अनदर पॉसिबिलिटी दैट दिस रिटर्न टाइम कैन बी रिड्यूस्ड, okay. If this return time can be reduced, that will be helpful for us, okay. So for that, basically this is the conversion of kinematic chain. We are calling it as a quick return motion mechanism. Quick return motion mechanism, okay. So why we are calling it as a QR mechanism, because QR motion mechanism, because quick return का मतलब है कि जितना whatever the time it is taking during the forward motion, it will quickly come over the original position. Fine. Now what we are assuming that मैं आपको थोड़ा सा explain कर देता हूँ. This is a crank, okay, which is connected with the another gear assembly inside the column, okay. This is the slotted bar or rocker arm, you can say, okay. This one is the rocker arm. Initially you can consider over here, okay, and it is final. So basically it is moving toward this side, and again it's coming, first it is moving toward this side and it is coming back on this side, okay. So because this is the tool head, okay, this is the ram assembly, okay, and this is the tool head, so means clapper box is mounted toward this side. So this should be the forward motion and this should be the backward motion, okay. So now initially you are fixing on the crank over here, okay, and then crank is rotating. So when it will rotate, this is fixed along with this slotted bar, a slot you have made inside this rocker arm. So inside this slate, the slot is nothing but there is a space is there. Okay, this is free. This is a complete free space inside just this. You can say that this is nothing but sometimes we say it's a block that slide inside this rocker arm, the block which is mounted. Sometimes we also say it's a slider. अगर आप theory of machine की language में बोलेंगे then it is a slider. Okay, so this slider is inside this slider means it will slide inside the slotted bar. So this moves when it will when this is rotating clockwise direction, it will start moving, rotating from this one to it will come to here, this position. Okay, this is the final. Now it has reached, like for an example, it is okay. Initially it was here. Now when it is rotating, this crank is rotating, this will give the reciprocating motion, so it will move up to here. Now it is reached up to here, then it is again has to move towards back side. So within this time only, मान लीजिए कि this is whatever the time has been taken over here, this time return time should be lesser than the forward motion. Okay, so from here to here it will come back to its original position during this time. Okay, now if you will see the angle, if you will see the angle, then during the forward motion, whatever from here to here, this is a forward motion. Okay, this one angle A is taken. Okay, now if you will see at 360 degree, means from here if you will start, then you can see that this A is greater than B. A is greater than B. ठीक है, मतलब जो आपका एंगल होगा ड्यूरिंग द फॉरवर्ड मोशन दैट इज ग्रेटर एंड द रिटर्न मोशन दैट इज लेस. ओके, एंड दैट्स व्हाट वी वांट. ओके, सो इसमें एक टर्म हम यूज करते हैं दैट इज R, दैट इज अ स्टेप रेशियो, or you also can say that is a gear ratio. So this step ratio is nothing but this is the time taken in forward motion. In forward motion upon time taken in return motion. ठीक है. Now देखिए this time taken for the forward motion is देखिए obviously you can see now that whatever the time has been taken that is greater than that is the in the return motion. और आप यहाँ पे इसको एंगल से भी डिफाइन कर सकते हैं कि that angle means whatever the angle covered during the forward stroke with respect to the whatever the angle that is covered in the return motion. Okay, so this is forward and this is for the backward, A by B. Now A is greater than B, and obviously whatever the time taken during the forward motion that is greater than the return motion, because during return there is no removal of the material from the workpiece. So that's why we wanted that it should come to its original position as soon as possible. So this ratio will be greater than 1 because A is greater than 1 for the time being. This R will be greater than 1. This R is nothing but here we are taking another ratio, that is quick return ratio. Okay, that is a quick return ratio and I am representing with small m. Okay, now this small m is nothing but reciprocate of this step ratio, that is 1 by R. Quick return matlab hai that is B by A. I'm just, if I'm simply right, this is B by A, that how much this is the percentage is showing that how much less time is taken during the return stroke as comparatively with the forward stroke. ठीक है, so this is B by A, so this is 1 by R. If this is 1 by R, this is B by A, then it will be lesser than 1. Okay, ठीक है, आपको ये थोड़ा सा ध्यान रहेगा. Okay, surface generated and effect of the feed. So this is like I said that this is the plate and we are moving toward this side and coming back. So here like initially we are keeping this tool over here. Okay, and we are giving a feed toward this side, means not feed, basically it's a reciprocating motion. So it is reciprocating motion में कितना feed देना है, maximum देखिए fix है. Now उस maximum fix का मतलब है कि आपका ये जो reciprocating है, जैसे मैंने यहाँ पे बोला आपको कि अगर मान लीजिए initially आपने यहाँ पे fix कर दिया है इसको, ठीक है, यहाँ से लेके यहाँ तक ही क्योंकि maximum initially यहाँ से start rotate हो सकता है और यहाँ तक पहुँचेगा. So this can cover only this much maximum is the length that covered by this machine. Okay, if you have to increase this machine, if you have to increase this reciprocating motion, then you have to use the large size crane. Okay, and large size, again this assembly will be increases. So whatever the length of the workpiece that you have to go for, means you have to remove machining, then it should be equal to this one or it should be lesser than this one. So if it is lesser than, then it can be manageable. Okay, that can be manageable. Now initially we are taking that tool over here, and we are as it is reciprocating, so it is moving toward this side and coming over here. So this is a forward motion. Okay, and again it will move back. Okay, so that is a return motion. So again it will come over here. Now what we have to do, that is again the important part, like here if it is moving toward this side and coming over here, now what you have to do, you have to give the feed, like this is a ring. Okay, and we cannot give the feed toward this side. So what you have to do, you have to push this workpiece toward this side. Okay, again it is a forward, then it is backward, then again you have to give the feed. Now this is basically the feed over here in the shaper machine. So now if you will see that this is the length. So now what you are doing is now the tool over here only, but this portion will come in contact. Now this area will come in contact. Is it clear to you guys? मतलब देखिए उसमें मैं क्या है कि आपको टूल को मैंने वर्क पीस मैंने बना दिया है. नाउ आई एम मूविंग टुवर्ड द टूल, बट ऐसा नहीं है कि टूल मूव करेगा, ऐसा नहीं टूल मूव करेगा, वर्क पीस ही मूव करेगा. ठीक है, तो this is like one pass is completed. Now for the second pass you have to move this tool over here, and this will move toward this side, forward motion, again backward motion, again this will be like this one. Okay, so इस तरह से आपका surface remove होता जाएगा. When you will see the surface profile, surface generated, it will be looks like this. ये रीजन क्या है इसका, कि मान लीजिए कि this portion is you are using the single point cutting tool. So obviously when you will give the feed toward this side, the little amount, because it is a point. Okay, point से आपका material remove हो रहा है. So now you can assume, okay, definitely there will be a wedge shape. Okay, now the effect of the feed, that if you are changing the feed, like मान लीजिए कि आप feed को, अब feed क्या है पहले मैं ये समझा देता हूँ कि this is your length. Okay, this is your width, just assume that. So that will be at the end, it will be good because we are summarized as well. Not summarized, we are standardized, making some standardized. So like if you have covered in a single pass, like this length has been covered and it is coming to the original position. Okay, now what you have to do, this is the single pass, for this is the second, this third, this fourth, up to like this. So how many passes should be required? How many, like this is nothing but a stroke. Okay, from here to here it is coming, this is the one stroke. Okay, sometimes in some of the books it's written that double stroke they are saying, because this is the forward motion, so this is the one stroke, and again it is coming back, so it is a double stroke. So please do not confuse. In some of the books it is written that only this complete is a one stroke, then another is a second stroke. Okay, but if it is written double stroke, then it means that it is coming and coming back. So this is the one stroke they are counting, another stroke this is counting. Okay, so this is a double stroke. So how much, like how many strength, how many strokes you have to manage. So like for that you have to move this tool toward this side. मैं आपको थोड़ा डेटा से समझा देता हूँ कि मान लीजिए कि आपका ये टोटल जो width है ये आपका 100 mm का है. ठीक है, and 10 mm you are taking in a single slot. Means when you are removing one stroke, that is removing 10 mm of the material. So if it is removing 10 mm of the material in a single stroke, then how many stroke you have to go? That will be equals to W by how many stroke we are taking. So this is 100 by 10. So that will be equals to 10 total number of strokes you needed. Okay, so that number of stroke, that is NS I am writing, that will be equals to what is the width of the workpiece upon what is the feed. Okay, this is what is the width of the workpiece what is the width of the workpiece upon feed. Now feed is what? Feed is that, now this is, we are calling it as a stroke. Okay, and during this time only the material is removed. So देखिए आपका मिलिंग में क्या था कि मिलिंग में लाइक number of teeth were coming in contact with the workpiece and they were removing the material. So that time we were considering the feet in mm per tooth. For that, we were considering the feet that is in mm per tooth. In the drilling and the lathe part, basically, whatever the material that was removed, we are giving a feed to the tool, or in the drilling, basically, it is rotating as well as we are giving a feed to itself only. So that time we were counting because the material was removing during the revolution. So that time we were counting the mm per revolution. Okay, this feed we were counting in mm per revolution. But here we are giving a feed. There is no rotation here, because if we are talking about the tool, we are not talking about the mechanism now. Okay, so this tool is just reciprocating, means we are providing a stroke in which the material is removed. Okay, so we are just calculating that how much amount of the material is removed in one stroke. Okay, so if this is the length, then feed will be represented as okay, this is like mm per stroke. Okay, now it's like if this is the length, then this length of the material is removed in one stroke. Then again you have to bring this tool over here and there will be another stroke. So whatever the feed that is given to you, that will be total feed. Okay, मतलब total आपका total length को count करने के बाद, तो क्योंकि आपका number of strokes भी कितने होंगे यहाँ पे 10 होंगे. So total length मान लीजिए कि ये आपकी 50 है, आपकी इसमें 50 mm लेंथ है. ठीक है, तो आपको total how much you have to move 500, that will be the total length, because आपका इसमें 50 हुआ, then again ये one stroke हुआ, then second stroke 50, then total 100, then next 50, that is 150, then next 50 200, then 250, then 300, then 450, 350, then 400. It's like that. Okay, so these things we have to keep in mind. Fine, so that is number of stroke is clear to you, feed is clear to you now. Okay, so next is we have effect of the feed. Effect of the feed, I just want to explain you that if you are taking, like here you are taking 10 mm per minute, 10 mm. Okay, so if you are increasing it, like number per stroke you are increasing, like if you are increasing 15 mm per stroke you have to take, if you have to take 20 mm per stroke. So three cases I am considering, that when you are taking this 10 mm, that time the surface profile will be generated looks like this. If you will increase the feed, it will be looks like this, and if you are moving from 15 to 20, it will be looks like this. Okay, surface profile. So now I think why I am telling, because what we are looking for, that is surface generated. So if the feed will be less, that time the surface profile which is generated, that will be satisfactorily or as per the requirement. Okay, तो इसका मतलब क्या है कि एक तो ये वैसे ही आपका प्रोडक्टिव प्रोसेस है नहीं, ठीक है, and now you are again you are why it is not productive, because you have to keep this feed is as less as possible. So again it will take a lot of time. Okay, so that's why we are not taking, that's why this process is not that much productive comparatively with the other processes. Okay, so it's clear to you now. Next is the hydraulic machine. Okay, this is a tank basically in which the hydraulic oil is filled. Okay, we are using this pump and this is the valve through which we can control the power, this fluid supply. Okay, there is another connecting, but by another connection, this connection is four-way valve which is connected to give the supply that because what the cylinder we are using over here. Okay, this is like two-way cylinder basically, through which basically the fluid can insert from this side as well as from inside as well. Means जहाँ से आपका insert हो सकता है वहाँ से आपका remove भी हो सकता है, ठीक है, back भी हो सकता है. So that's why we are calling it as a four-way cylinder. ठीक है, first you can move toward this side, remove this side, insert this side and remove this side. Okay, so this is first, second, third and fourth way. Okay, so this we are calling it as a four-way. Same the wall condition. So what we are doing is first this is the hydraulic cylinder assembly. Through this mechanism we have connected with the rim. Okay, so now this is from here and here, this is moving toward in between that one. So when the fluid is coming, like just assume that this is the piston. The piston is initially over here and you are supplying the fluid. So fluid is hydraulic fluid, and when it is moving inside the cylinder, hydraulic fluid, it has a it will apply equal amount of the pressure on the piston, because when it will flow toward, or first it will cover all the cross sectional area, then it will move towards the piston. Okay, so it is when the piston is initially over here, as the fluid will come inside, that will basically move this one piston and it will move toward this side. So this mechanism is connected with this link, so it will also move towards this side. Now once it will reach over here, what you have to do, you have to switch off this motor, this whatever the pump is there, that you have to switch off. Then, or if you are not switching off, then you have to take care of this four-way valve. Okay, that is very important at that time. So what you have to do, you have to immediately release. First you inserted this fluid, now you immediately release this fluid, because you have to again insert this fluid from this side. Okay, from this side. So now when it will insert fluid insert in this side, then it will push this piston, so it will move towards this side. Or again, when it will move toward this side, immediately you release this fluid from this side only. So four-way. Now it's clear to you. So this is the way through which the hydraulic shaper work. Okay, so again it is the same process that as I told you in the beginning, that there's a circular disc is there, over that we have fixed a key, and in which the slotted bar is fixed. So forward during the time, basically during the forward motion and the return motion will be same. Okay. Now the velocity profile for the conventional and the shaper machine. Conventional is nothing but for that we are using the quick return motion mechanism. So like इसमें मैं आपको एक तो बता ही चुका था, जिसमें आपका सिंपल सर्कुलर डिस्क ले रहे थे. Next, this is the cutting velocity toward this side, and this is positive and this is negative. Okay, this is time. This is time. This is positive and negative. This is velocity. Okay, this is zero. Okay. Now if you will see for the conventional part, if you will see, then we need the less time during the forward motion. Okay, so this is the forward motion, that from here we have started and from up to here we have reached to the final position. And as we need as we have to come back very fast, then the velocity will be very high during this time. Okay, so this is the velocity profile. Here maximum it will come here at 20 is, it will be like this. Okay, please keep in mind these things. Now when you will talk about the this one hydraulic, then initially, like, first the fluid will come inserted inside the cylinder. First it will cover its area, then it will start pushing the cylinder piston. Okay, now immediately after that we have to release this fluid. Fine. And again it will be looks like again we have to remove it, then we will push it, then again we have to release it. So this velocity profile will be looks like this one. Okay, so okay, now the important thing is because that also we have not discussed the velocity. We are talking about here the velocity. From the past three machines, when we are talking about the cutting speed, that time we were using that V will be equals to pi into D into N, because cutting speed is nothing but that is affiliated with the tool. That is affiliated with the tool, because this rotational speed we are saying, this is D we are saying. In the single point cutting tool also the velocity was affiliated with the tool. In the drilling also the cutting speed was affiliated with the tool. In the milling machine same. But here the tool is here also the cutting speed is affiliated with the tool only, but it is not rotating, it is reciprocating. Okay, and it's reciprocating जो है आपका वो इस तरह का नहीं है. देखिए ये मान लीजिए कि ये जो प्रोफाइल है आपकी, ये इनिशियली आपकी बनती रहेगी. ठीक है, उसके बाद क्या होगा कि आपका जो ठीक है, मान लीजिए कि हम ऐसा करते हैं कि यहाँ से हमने स्टार्ट किया, फॉर एग्जांपल यहाँ से हमने स्टार्ट किया, बोथ आर इक्वल. यहाँ से हमने स्टार्ट किया, देन इट इज मूविंग टू द मैक्सिमम, देन अगेन इट इज बिकम जीरो, एंड अगेन इट इज मैक्सिमम एंड इट विल बिकम जीरो. इट्स हैपन लाइक दिस ओनली. ओके, बट व्हाट वी हैव डन इज, देखिए ये जो फिगर है, दिस इज लाइक हियर इट इज इनिशियली यू हैव केप्ट इट. ठीक है, देन इट इज रोटेटिंग लाइक दिस, एंड बिकॉज यहाँ से अगर आपने इनिशियली स्टार्ट किया, देन इट हैज अ वेरी मतलब जीरो वेलोसिटी, बिकॉज इट इज नॉट रोटेटिंग, इट इज फिक्स्ड, मतलब स्टेशनरी है आपका. देन यू आर गिविंग अ रोटेशन. व्हेन यू आर गिविंग अ रोटेशन, अगेन आपका यहाँ पे आके क्या है, आपको उसको स्टॉप करना है, बिकॉज इट विल स्टॉप ओवर हियर. सो यू हैव टू स्टॉप, एंड अगेन here it is velocity is zero, here also it will velocity will become zero. So it means that during this portion the velocity is increasing, it is maximum, again it is coming, it is decreasing and becomes zero. Okay, means आपका अगर मैं रेसिप्रोकेशन में कहूँ तो यहाँ पे आपका वेलोसिटी 0 है, यहाँ पे आपकी वेलोसिटी 0 है. सो दिस वेलोसिटी इज इंक्रीजिंग डे बाय, मतलब धीरे धीरे आपका स्पीड होगा इंक्रीज होगा, देन इट विल रीच टू द मैक्सिमम एंड अगेन इट विल डिक्रीजिंग. ओके, ऐसा तो है नहीं, ऐसा ही है. So if this is the horizontal path, then we can say that this velocity profile, this is like increasing, it will become maximum and again it will become 0. During the return stroke, we have to move it very fast. So very fast means at the same time this will be maximum and this will be become 0. Means it is increases very sharply as comparatively with the forward profile, this one profile. So this is increases very sharply, again it will become 0. Fine, it's clear to you now. So that's why we are keeping this profile like this one. Like if this velocity is not constant throughout the process and it is 0 to maximum, maximum to 0, it is, and obviously maximum also we cannot say that this will be the maximum, because in this case during that time only the velocity is increasing. So what we have to do is, here we cannot take this velocity as a pi dm. Here the velocity profile, velocity will be, that is how much length you are covering into what is the rotational speed of this crane. Okay, so that rotational speed I am taking, that is L into M. But here the ratio is very very important, quick return ratio, because overall whatever this terminology also we can explain on the quick return motion, quick return ratio, because that is nothing but the B by A. Okay, means how much angle you are covering during the return stroke and with respect to how much angle you are covering during the forward stroke, or time also we can take. So this is L into N into 1 plus M. Okay, upon 1000 you can take, because that will be at the end we are calculating in meter per minute. So if length is in mm, so you can divide by the 1000. So this is the velocity that we are giving. Okay, so now the machining time, when it is moving from here to here. Okay, so this is the machining has been done, but again it has to come back. So that time the machining time will be, and we are considering this is not a double stroke, this is single stroke only. Okay, so this time will be equals to L into 1 plus M, that how much ratio we are taking upon V. So if this is in mm, so we can take it in 2000. Okay, so that is the minutes. But now this time is for the how much length we are covering. How much length we are covering means if initially tool was here, now it has been covered this length, so up to this one only. Okay, now we are going back as well. Okay, so that is the total machining time. Okay, this is the one stroke total machining time, means it is coming here and removing and again coming here. So this is the machining time. Okay, now what we have to do is this is for the one stroke only. Okay, there are number of strokes. How many strokes are there? That is ns, and that will be equals to W by F. So if we have to give the total machining time, then that will be equals to Tm, whatever the machining time that you are getting in from here, into ns, that is a number of stroke. Okay, so this will be the final machining time. Okay, okay, let's move to the calculation part. Calculation is done. Okay, this velocity, that is this one only, that is n into L upon into 1 plus M upon 1000. Okay, this is in meter per minute, and this Tm, that is the machining time, that is L by L into 1 plus M upon V. Okay, and total machining time will be equals to, total time will be equals to Tm into ns only. Okay, so this is your simple calculation. Fine, let's move to the problem part. That is cutting speed of the tool in mechanical shaper is, let's see the options which is available. Maximum at the beginning of the cutting stroke. देखिए cutting stroke के इनिशियल लेवल और फाइनल, मतलब इनलेट और एग्जिट पे आपका 0 रहती है. ठीक है, तो मैक्सिमम तो नहीं होती. सो दिस विल बी रॉन्ग ऑप्शन. मैक्सिमम एट द एंड ऑफ द कटिंग, एट द एंड ऑफ द कटिंग स्ट्रोक. सो अगेन इट इज, इसको देख लेते हैं पहले डी को. मिनिमम एट द मिडिल ऑफ द कटिंग स्ट्रोक. देखिए आपका इनलेट पे ही, बिगिनिंग और एंड पे ही अगर आपका 0 है तो उससे मिनिमम और कितना होगा. सो दिस इज अगेन रॉन्ग आंसर. सो ऑप्शन विल बी सी, इट इज मैक्सिमम एट द मिडिल ऑफ द कटिंग स्ट्रोक. ठीक है. नेक्स्ट इज a cast iron block of 200 mm. देखिए ये क्वेश्चन मैं करा देता हूँ. This asked in GATE 2014. Cast iron block of 200 mm. So the length of this is given to you. Okay. is being shaped in shaper machine with a depth of cut of 4 mm, means D is given to you. Feed is that is 0.25 mm per stroke. Okay. Tool principal cutting edge angle is 30. This 30 degree. It's not this one. This 30 degree. The number of cutting stroke per minute is 60. Means NS will be given to you, that is 60, and that is per minute. Okay. Specific using specific energy for cutting as 1.49 joule per mm cube. The average पावर कंजम्पशन, देखिए ये मुझे ऐसा लगता है कि शेपर का प्रॉब्लम है ही नहीं, ठीक है। जो हमने लेथ के टाइम पे जो मशीनिंग पढ़ी थी और उसमें हमने पढ़ा था कि लाइक स्पेसिफिक एनर्जी कंजम्पशन, ये उसी का कंसेप्ट है बेसिकली, ठीक है। तो स्पेसिफिक एनर्जी को हम किस तरह से रिप्रेजेंट करते थे, स्मॉल यू से। स्मॉल यू क्या होता था, दैट इज टोटल पावर कंजम्पशन अपॉन मटेरियल रिमूवल रेट, ठीक है। नाउ आपको क्या कैलकुलेट करना है, पावर कैलकुलेट करनी, सो P विल बी इक्वल्स टू U इनटू MRR, ठीक है, मटेरियल रिमूवल रेट। नाउ U इज गिवन टू यू, दैट इज joule, that is 1.4 joule per mm cube. Okay, now this material removal rate. Material removal rate is how much? That is, if you are removing this length, that is material removal rate in case of shaper will be equals to L into what is the depth of cut you have taken, like is sorry. ओके, सो मान लीजिए कि आपका फर्स्ट आपने ये स्लोट जो है आपको ये रिमूव करना है, ठीक है। जो टोटल लेंथ आपने इसमें कवर की है, इनिशियली दिस डेप्थ ऑफ कट यू हैव टेकन, जो टोटल लेंथ आपने कवर की है दैट इज 200 mm, ठीक है। सो नाउ वॉल्यूम कितना होगा, मटेरियल रिमूवल रेट क्या होती है आपका, हाउ मच अमाउंट ऑफ द वॉल्यूम इज रिमूव्ड पर यूनिट टाइम। तो देखिए आपका फीड दिया है, दैट इज इन स्ट्रोक्स पर means this number of stroke is given to you, that is in per minute. Okay, so the feed length, how much length we will cover, how much depth of cut will be given, that will be the cross sectional area. So this L into D, that will be the cross sectional area, and how much amount of the material is removed per stroke, that is small f, and how much number of strokes you are taking in that. Okay, so this will give you mm per minute. Okay, so this length will be equals to 200 into feed, that is 4 into sorry, depth of cut is 4, feed is 0.25 into NS. NS is how much, that is 60. So this is per minute, so I am calculating in per second. Okay, so this will be like 60. Okay, so this will be mm cube per second, so this will be cancel out, and from here what I will get is okay, so from here I am getting that is 200 mm cube per second. Okay, this is material removal rate. Now just I have to place it over here, this U, that is 1.4 into MRR will be equals to 200. So when you will calculate, the power will be 298 watt. Okay, because meter cube per second है आपका यहाँ पे, ठीक है। तो this will be cancel out, this will be joule per second, so joule per second is nothing but watt, so this will be the final answer. Okay, 298, ठीक है, 298 watt. Next, ठीक है, इजी है, बाय द वे दैट्स व्हाई आई टोल्ड यू दैट ये आपका शेपर का प्रॉब्लम है ही नहीं, ठीक है। शेपर का प्रॉब्लम सिर्फ इस वजह से काउंट कर रहे हैं हम लोग क्योंकि फीड जो है वो mm पर स्ट्रोक में दिया है। अगर mm पर रेवोल्यूशन में होता तो हम इसको सिंपल लेथ या फिर ड्रिलिंग का भी काउंट कर सकते थे, ठीक है। ओके, सो नेक्स्ट देखिए, नेक्स्ट दो प्रॉब्लम्स हैं, इनमें से मैं एक करा देता हूं बिकॉज बोथ आर सिमिलर। ओके, देखिए a 600 into 330 mm फ्लैट सरफेस, ठीक है, आपका ये दिया है बेसिकली, दिस इज ओके, जस्ट assume that this is 30, this is basically this one. ओके, दिस वन, ये आपका टॉप व्यू है, मैं आपको टॉप व्यू बता रहा हूं, ठीक है। तो दिस इज 30 एंड दिस इज 600, ठीक है। सो दिस इज 30 एंड दिस इज 600, ठीक है। नाउ फ्लैट सरफेस ऑफ अ प्लेट टू बी फिनिश machine on a shaper. The plate has fixed with 600 mm side along the tool travel direction. tool इसका मतलब क्या है कि आपको यहाँ पे इनिशियली टूल फिक्स करना है, देन दिस विल बी द फॉरवर्ड मोशन, तो आप यहाँ पे यहाँ तक रीच करेंगे, देन अगेन यू हैव टू ब्रिंग इट ओवर हियर एंड यू हैव टू गिव द फीट टुवर्ड दिस साइड. मींस व्हाट इट वांट टू से इन दिस सेंटेंस दैट यू हैव टू फिक्स इट दिस साइड. ओके, आपको इस तरह से मूव करे, ना कि ऐसे मूव करे. इस तरह से मूव नहीं करना चाहिए, ठीक है, इस तरह से मूव करना चाहिए. दैट इज व्हाट इट्स मेंशन. ओके, if the tool over travel at each end of the plate is 20 mm, इसका मतलब आपको अभी तक हमने क्या है, जैसा हम पहले करते आए थे कि अप्रोच प्लस ओवर ट्रेवल, तो ये आपको गिवन है. दिस इज यहाँ आपको यहाँ से स्टार्ट नहीं करना है, यू हैव टू टेक सम अप्रोच. दिस इज लाइक अप्रोच, यहाँ से आपको टूल स्टार्ट करना है, सो दिस विल मूव एंड एट द एंड एज वेल यू हैव टू टेक सम over travel. Okay, so this will be complete finishing should be placed on the workpiece. So now we are moving from here to here. Okay, so this will be the total length. Okay, average cutting speed, which is 8 meter per minute, is given to you. Feet, that is 0.30 mm per stroke, is given to you. Ratio of return time to the cutting time is 1:2. That is m will be equals to 1/2. Okay. The time required for the machining in minutes. So the time is how we are calculating, that is machining time will be equals to L into 1 plus M upon V into 1000. Okay. Now now L is the total length. यहाँ पे क्या है, वर्क पीस की लेंथ कितनी है आपकी 600, but total length will be equals to approach plus over travel plus length. So this will be equals to approach plus over travel plus small l, that is the length of the workpiece, into 1 plus m upon 1000 into b. ठीक है, अप्रोच कितना है आपका 20, ओवर ट्रैवल कितना है आपका 20, लेंथ कितना है 600, ठीक है, into 1 plus m, so 1 plus 0.5, so this will be okay the side 1.5. ठीक है, next is 1000 into v is how much, v is that is 8 meter per minute. So whatever the term that you will get from here, that will be like that will be in minutes, because this is you are taking in meter per minute. Okay, so this was in mm, so that's why you are taking this 1000, so that will be converted into meter, so this is in meter per minute. So whatever the value that you will get, that will be in minute from here. So what I am getting is okay, so I have to calculate this one. This will be like 640 into 1.5 divided by 8000. Okay, so this I am getting is 0.12 minutes. Okay, but ये option में तो है नहीं कहीं पे. So what we have forget that this machining time is nothing but for the one stroke. How many strokes are there? So we have to think that what is the width, because initially we have taken this feet, we have taken like this is 0.3 mm per stroke. तो इसका मतलब है आपका जो ये रिमूव हुआ है, देखिए डेप्थ ऑफ कट अलग चीज है इसमें, ठीक है, ये जो आपका ट्रैवल हुआ है, दिस ट्रैवल इज 0.3 mm, नेक्स्ट दिस विल बी 0.3, नेक्स्ट इट विल बी 0.3, नेक्स्ट इट विल बी 0.3, इट विल बी लाइक दिस. तो इस तरह से कितना चलेगा, सो दिस नंबर स्ट्रोक विल बी इक्वल्स टू W, दैट इज विड्थ अपॉन फीट. विड्थ कितना है आपका, दैट इज 30, फीट कितना है आपका, दैट इज 0.30, सो दिस विल बी इक्वल्स टू 100. ठीक है, ओके. नाउ जस्ट मल्टीप्लाई दिस वन विद दिस. So total time or total machining time will be equals to Tm, that is 0.12 into how much, that is 100. So this will be equals to 12 minutes. ठीक है, so option will be B. देखिए next जो problem है 75 that asked in ISRO 2008. So that is similar problem basically what we have done in the previous one, that has the same problem. Okay, so I giving you this into the homework. ठीक है. So thank you so much guys for joining this session. See you soon.